Hi everyone, welcome back. We are now on 11.4, which is all about tree diagrams. If you're a visual person, this will help you visualize, what we're looking at with probability. So we're going to talk about a very important principle. It's called the fundamental counting principle. We'll start off with a question. I want you to think about if you had a coin, so you've got heads and tails, and a die. So you've got the numbers 1 through 6. How many possible outcomes will you have if you toss a coin and you roll a die? Okay, just think about that. So if we break this down, we call tossing a coin. So if you remember when we did sets, we're going to write a set. We'll call it M. So set M, when you toss a coin, the only possibilities are heads or tails. And rolling a die, we'll call that set N. So my only possibilities are 1, 2, 3, 4, 5, and 6. So how many possible outcomes would I have? According to the counting principle, if a first experiment has M distinct outcomes, so distinct just means different, which we do. H and T are completely different. One's heads, one's tails. And in set N, all those numbers are different, 1 through 6. Then the two experiments in that specific order have M times N distinct outcomes. So in set M, I have 2 outcomes. And in set N, I have 6 outcomes. And the counting principle says just multiply them and you'll get 12. So you would actually have 12 different outcomes. And you'll see why we would have 12 here if I scroll through. If we look at something called a tree diagram, which is a visual way of looking at what's called a sample space. That's the list of all possible outcomes of an experiment. So when they say sample space, they're referring to here's all your possibilities. And if you count them, there's actually 12 different outcomes or possibilities. And we got that from 2 heads and tails times 6 faces on a die. 2 times 6 is 12. So you could get a heads and you could roll a 1, or you could get a heads and a 2, or a tails and a 3. There's 12 different outcomes. Each one of these outcomes is referred to as the sample point. So H1 is a sample point, and H2 is another sample point, and so on. Okay, so let's go back now and use the counting principle, again, dealing with a standard 52 card deck. How many possible outcomes would you have if you draw 2 cards? So 2 cards are drawn from a standard 52 deck. How many possible outcomes if the cards are drawn in 2 ways, one of them with replacement and the other without replacement? So there's a big difference. Picture you have 52 cards, right? And so I know that I'm starting out with, when I have those 52 cards, there's 52 possibilities. Okay, I take a card and then I put it back. I still have 52 possibilities. So to find the number of possible outcomes, I'm going to take 52 and multiply it by 52. So set M, the set of cards that you start with, has 52 cards in it. And since you take a card and put it back, set N still has 52 cards. So if I use the counting principle, 52 times 52, I end up with 2,704 different possibilities. I mean, if you think about it, you could roll, you could choose an ace and an ace, or an ace and a 2, or an ace and a 3, and so on. And there's all those different suits. So the 2 of hearts, the 2 of clubs, the 2 of diamonds. That's a lot of possibilities. There's 2,704. So how does that change now if you don't replace the card? So what this means is you start out with set M, you have 52 cards. Since you pick a card and you don't replace it, now you only have 51 cards. So if I multiply, I'm multiplying 52 times 51. So now I have 2,652 possibilities. Why does it make sense that I have less possibilities? It's because you just limited, by keeping that card that you picked the first time, you just limited the number of other cards that are left and the number of options. Pause the video and try the next problem about Pinochle, which is a card game played with a deck that contains 48 cards, and then unpause when you're ready to go over it. Pinochle is a card game played with a deck that contains 48 cards. If 2 cards are drawn from a Pinochle deck, determine the number of possible outcomes if the cards are drawn with replacement or without. So if you're replacing, both of your sets will have 48 cards. So it's just 48 times 48, which comes out to 2,304 different possibilities. Now, if I'm not replacing, that means I start with 48 cards, but I am going to then not replace one of them. So now I only have 47 cards. So 48 times 47 gives me 2,256 cards. So again, it's a smaller sample space because you're removing a card. So you're removing a possibility. Let's look at those same types of problems, but let's make tree diagrams to visualize. A radio station has 2 tickets to give away to a Monster Jam truck rally. It held a contest and narrowed the possible recipients down to 4 people. Christine, which will be the letter C, Miguel, M, Lavan, L, and Priyanka, P. The names of 2 of these 4 people will be randomly selected from a hat, and the 2 people selected will be awarded the tickets. So first of all, determine the number of sample points in the sample space. So I've got 4 people and their names in a hat. So my first set is going to have 4 possibilities. It could be Christine, Miguel, Lavan, or Priyanka. But your next set is only going to have 3, because once you choose a name, there's only 3 people left. So 4 times 3 is 12. So there's going to be 12 sample points in that sample space, because once that first person selected, out of the 4, only 3 are left. Okay, now what does that look like visually? Let's take a look at the sample space and the sample points. So if you visualize this, right, we've got Christine, Miguel, Lavan, and Priyanka, okay? And that's for my first selection. So I'm going to choose one of those, and I'm going to have 3 names left. So if I choose Christine, my only options left are Miguel, Lavan, or Priyanka. If I choose Miguel, my only options left are Christine, Lavan, or Priyanka. If I choose Lavan, my only options are Miguel, Christine, or Priyanka. And if I choose Priyanka the first time, my only options are Miguel, Lavan, and Christine. So this represents my second selection. So my sample space is going to be each of these combinations. So first I'm going to have Christine and Miguel. And then I'm going to have Christine and Lavan. And Christine and Priyanka. And then I'm going to move down to the M's and just go straight across. You've got Miguel and Christine, Miguel and Lavan, Miguel and Priyanka. And you're going to do the same thing with the L and the P. So as you can see here, we came up with 12 different sample points, right? Each of these is a sample point. So there's a sample point, there's a sample point in your sample space. So we have 12 different sample points. And this is a visualization. So this will help me now determine letter C and D. So letter C says determine the probability that Christine is selected. Okay, so Christine selected. Let's take a look at this. Everywhere Christine selected, I'm going to highlight. So I've got Christine, Christine, Christine. Everywhere there's a C. So I counted here 6 different places that Christine is selected. So if you remember, how do we find probability? And we're looking at theoretical here. So the probability is just the number of favorable outcomes, so the number of times I chose Christine, over the total number of possible outcomes. There's 12 different possible outcomes. So the probability Christine is selected is 6/12, which we know we're going to reduce to 1/2. Letter C says, determine the probability that Christine is selected and then Miguel is selected. Okay, so Christine and then Miguel. So the only place that that is occurring is right here. Christine is selected and Miguel is selected. There's only one time that happens. So that would be 1/12. Pause the video and try the next one on your own. At 2J's Deli, each lunch special consists of a sandwich, a salad, and a beverage. The sandwich choices are roast beef, ham, or turkey, and the salad choices are macaroni or potato, and the beverage choices are coffee or soda. Determine the number of different lunch specials offered by this restaurant. Okay, so I'm going to use the counting principle. We know that when we go to a lunch special, it consists of a sandwich, a salad, and a beverage. So how many sandwiches are there? There are 3 different sandwiches: roast beef, ham, and turkey. And then I'm going to look at the number of salads. How many salads? There's macaroni or potato. And last but not least, I'm going to look at the number of beverages, which are coffee or soda, and that's 2 as well. The counting principle tells me to multiply those together. So when you multiply 3 times 2 times 2, you get 12. So there's 12 different options for you at this lunch. If you have a hard time of visualizing it, let's make a tree diagram and see what this is going to look like. So first I'm going to have my sandwiches, which would be roast beef, ham, or turkey. Then you can choose a salad. So what types of salad? You've got either macaroni or potato. And then you can choose a beverage. So what are your beverage options? Coffee or soda? And now I have my sample space made up of 12 different sample points. And I'm just going to go straight across, right? So I'm going to start here and go RMC. So you could choose a roast beef sandwich, macaroni salad, and coffee. Or you could get roast beef, macaroni, and soda. Or you could get roast beef, potato salad, and coffee. Or roast beef, potato salad, and a soda. And I'm going to move down now to the H's. You could just go straight across. You could get a ham sandwich, macaroni, and coffee. Or you could do ham, macaroni, and soda, and so on. Now we're going to use those to answer the question. So if a customer randomly selects one of the lunch specials, determine the probability that a roast beef sandwich and a soda are selected. Okay, so everywhere there's a roast beef sandwich and a soda. So I've got roast beef and soda here, roast beef and soda there. And they're the only 2 places. So the probability is 2 out of 12, and 2/12 reduces to 1/6. If a customer randomly selects one of the lunch specials, determine the probability that neither macaroni salad nor coffee is selected. So neither and nor basically mean not macaroni or coffee. So I'm going to go through and I'm going to count how many places we don't have macaroni or coffee. So in that first one, I've got coffee and macaroni. In the second one, I've got macaroni. In the third one, I have coffee. In the fourth one, this is one that doesn't have macaroni or coffee. So everywhere, as long as there's not an M or a C, it's okay. So there's 3 places that there's no macaroni or coffee. It's if I get a roast beef sandwich, potato salad, and soda, or a ham potato salad and soda, or a turkey and potato salad and soda. So that's 3 out of 12. And 3/12 reduces to 1/4. In the next example, 2 marbles are to be selected with replacement, so that's important. From a bag that contains 1 red, 1 blue, 1 green, and 1 orange marble. So we know that's a total of 4 marbles in a bag, and you're choosing 2 marbles, but you're replacing it. So you pick one, you put it back in. How many different sample points are in the sample space? So in your first set, you've got 4 marbles to choose from. You pick one and then you put it back in the bag. So there's still 4 marbles in there. So 4 times 4 gives you 16. There's 16 sample points in the space. And let's look at what that would look like with a tree diagram. So you've got red, blue, green, and orange. And out of each of those 4 colors, I'm going to have 4 branches because remember, you're putting them back. So there's a chance you could get a red and a red, or a red and a blue, a red and an orange, or a red and a green. And all of these are going to have 4 different branches. And they're all going to have R, B, O, G. So I could have a red and a red and a blue, a red and an orange, a red and a green. And then I could have a blue and a red, a blue and a blue, blue and orange, blue and green, and so on. Okay, and I'm kind of running out of space, so I'm just going to start listing them over here for green and orange. So you can count, there's 16 sample points in your sample space. What's the probability a red marble is selected twice? So the only place where you've got a red and a red is right there. That's 1 out of 16. So the probability is 1/16. Here we have the word neither again. So that's very similar to the problem we just did when they said neither macaroni salad nor coffee. So again, determine the probability that neither marble selected is orange. So that means not orange. That's what that means. So it can't be orange, orange. Not orange and not orange. So we're looking here where there's one spot where it's orange, orange. And there's other places that are orange as well, right? So it's not just that one. So it can't be, either one of them can't be orange. So I'm going to highlight that in yellow. Anywhere there's an orange, we can't count it. So this is not going to count. This is not going to count. Any of these orange ones don't count, and that one doesn't count. So how many of them did I not highlight in yellow? So there's 1, 2, 3, 4, 5, 6, 7 that are yellow. So I'm just going to subtract 16 minus 7, and that leaves me with 9 out of 16 that are not orange. One or both of them. And then the last one says, determine the probability that the orange ball is selected at least once. So remember, at least once means once, one or more times. But we're going to look at another way to find that here. So orange at least once, that would be the 7 that I highlighted. So that would be 7 out of 16 that have at least one orange. So 1 or 2 in this case. So that word at least is going to come up often in the chapter. And one of the ways that we can look at least is using this formula, which is the probability of an event happening at least once is just 1 minus the probability the event doesn't happen. So if we look back at the last problem we did, letters D and E, if I want to find the probability that you get at least one orange, all we're going to do is take 1 minus the probability that we get no orange. So remember, the probability you don't want an orange is 9/16. And 1 minus 9/16 is just 16 over 16 minus 9 over 16, which is 7 over 16. You get the same answer. Okay, let's look at an example. So suppose you're planting flowers and the probability of not getting any red flowers is 2/7. What's the probability of getting at least one red flower from the seeds that are planted? So here, I'm looking for the probability that you get at least one red flower. So my formula says just do 1 minus the probability that you don't get any red flowers. So 1 minus the probability of no red flowers. So the probability of you not getting any red flowers is 2/7. So it's just 1 minus 2/7, which is 7/7 minus 2/7. And that leaves us with 5/7. So the probability that at least one of those flowers will be red is 5/7. All right, if any of you have any questions with anything we've discussed so far, please feel free to ask me. Please make sure you're working on homework. You have so much control over your homework. You can just keep redoing questions if you need to until you get a good score. You want to maximize your grade for the class by doing the best you can in the homework each time. And as always, if you have any questions, please reach out. All right, enjoy the rest of your day, everyone.